Okay, yeah. On this question, right, they say we should use the formula for computing roots of unity to solve the following equations, right? So, what we should do here, first thing that we need to know is the formula for computing the roots of unity. Now, remember that, actually, let me first write the formula. The formula is like this, where we have uh, the modulus of z to the exponent 1 over n. And then we have cos of theta, or we can call it arg of z, right? Plus 2 pi k all over n plus I sine theta plus 2 pi k over n. But how did we get to this formula? That is the question, right? So we can say that we remember from polar form, where remember that z is equals to r, which in this case is the modulus. Is the same thing, right? You can exchange that and write r cos of theta plus I sine of theta, right? And we remember that this polar form can also be extended to say, let's say now here, we remember that for the roots of unity, if we have z to the n equals to 1, this is how they actually pointed out this condition, right? So for us to have this, let's just assume that z of n, it's to the exponent n, because we're going to find it the roots of infinity to the exponent n, right? The roots of unity to the exponent n. So we plug this inside there. So this is cos of theta plus I sine of theta. We get that, right? Now from here, we multiply both sides, or we exponent both sides by 1 over n, put the exponents both sides 1 over n, then we're going to get r cos of theta plus I sine of theta to the 1 over n. If we put this both sides, this one will cancel out, right? And then here, we can apply the Mobius theorem. All this is coming from SMTA012, right? We can apply the Mobius theorem. The Mobius theorem says that when I apply it, I'm going to put the 1 over 2 there, the 1 over n there. Then I have the cos. The 1 over n will come here and multiply. So this will have pi theta over n plus I sine theta over n. But ourselves, we are looking to work with this plane. Remember, we are going to be revolving around this plane. Sometimes you'll find yourself having 8n or changing something. Let's say changing 26 over 3, 26 pi over 3. You'll find yourself having something like this and so on, right? Yeah, it means that this can revolve as many times as it can. We know that revolving once will give us 2 pi, right? So it means that since we're going to revolve more than once, or sometimes we might even move from here to here or from here to here, we might want to check the angle from here to here and so on. It means that we can now come and say that we are going to multiply, or we are going to add actually to our angle by 2 pi k over n. We're supposed to add by 2 pi if it was a revolving once, but we are saying that it can revolve as many times as it wants, right? So we can just keep that k, and it is possible for it not to revolve at all. So that's why our k is going to start from 0, right? Theta plus 2 pi k over n. That's why we'll say that our k is going to start from 0, 1 up until n minus 1. So here I can even put zk. So allow me here to put zk. Right. So now here's how we find the formula. I'm sure we can say this. Now, since we know how to find the formula, we can come here and say that we need to find the question that we're given there. They say we need to find z to the 5 is equals to 32. So one thing I can tell you here, if you want to find this, what you have to do, you have to come and say z to the 5 equals to 32 implies that z to the 5 is equals to 32. We write this in a complex number form, right? We have this is going to be 1 plus 0i, which now we write it in complex in actually the polar form. This is going to just be 32 cos of, we need the angle, plus I sine of, we need the angle, right? Now, for us to check the angle, we are going to look at this. We are going to look at this for us to check the angle. If we check this, this is the pair 1, 0. Remember, this pair is supposed to be AB, and this is the form of A plus BI. You see, right? And this, now we say, remember in SMTA012, we used to say that first we would say this, would say that Z is in there. You specify the plane. So let's check the plane. Here, A is positive 0, B is 0, right? A is positive, B is 0. It means that our plane is, let me write these angles first. 3 pi over 2. If you want to know, right, this is how you write these things. It's 0 pi over 2, which gives us a 0. Here it's 1 pi over 2, which gives us pi over 2. Here it's 2 pi over 2, which gives us pi. And here it's 3 pi over 2, which gives us that, right? Now, this is where A is greater than 0 and B is equals to 0. You see, right? Here it's where A is greater than 0. No, A is equals to 0 here. And B is greater than 0. So A is for our real axis. Remember, this is the real axis. This is the imaginary axis, right? So here we're going to have A equals to 0, because this is the imaginary, so the real axis there is 0, and B is less than 0. Here it's where A is less than 0 and B is equals to 0. So if we check here, we have Z is in there, we have this, right? It's in the positive real axis. It's in the positive real axis and has the pair or has a pair 1, 0. So the angle here will be 0. You see right now? So it means that our angle here is going to be 0, 0. So we have written this in a polar form. So it means that already we know that our R is going to be 32 and our N is going to be 5 and our theta is going to be 0 and also our K is going to be 1, 2, 3, 4. Remember, this is saying up until n minus 1. N minus 1 is 5, right? So we have this 4. We only need this 4, right? Now we come and write the formula. The formula, remember, it was saying Z of K is equals to, we can even use R instead of the modulus of Z. And then this is cos of theta. Let me just write the formula first, right? Theta plus 2 pi K all over N plus I sine of theta plus 2 pi K all over N. Now, if we check here, we are having Z over K, which is equals to our R is 32, 1 over 5 cos of 0 plus 2 pi k all over 5 plus I sine of 0 plus 2 pi k all over 5, and this will be this is 2, right, and this will be cos of 2 pi k over 5. Remember, you said we don't use a calculator, right? Sine over 2 pi k over 5. So now we have simplified this to this format, right? Now we are going to check our k, z of k one by one. So we say z of 0 is equals to 2 cos of 2 pi 0 over 5 plus I sine of 2 pi 0 over 5, and this is equals to 2 cos of 0 plus I sine of 0, and this is equals to 2 cos of 0, we know that it's 1, sine of 0 we know it's 0. That is something that you should be knowing by now, right? If you didn't, then this will be 2. You can just say is 2 plus 0I, which is 2, right? Now if we check something here, the only thing that will be changing is this. If we check, we can always check. The only thing that will be changing is this. Let's look at the other one. We have z of 1 is equals to 2 cos over 2 pi 1 over 5 plus I sine of 2 pi 1 over 5. If we check, the only thing that changed is this. The formula is still the same. You see, right? And this will be equals to 2 cos of 2 pi over 5 plus I sine of 2 pi over 5. Now, we can, for this one, we can stop here, right? Because we don't have this angle in our plane without using a calculator. And I'm sure that if we use a calculator here, it's going to give us some decimal numbers, which the lecturer, you saw, they said that if we would get decimal numbers, they're going to subtract marks, right? Then now we have 2 pi over 2 over 5 plus I sine of 2 pi 2 over 5, which this will be equals to 2 cos of 4 pi over 5 plus I sine of 4 pi over 5. And this, we can change this angle. All right, this angle can be changed because it's a bit bigger, a little bit bigger. So we can change it to say this is 5 pi minus pi. Can change the 4 to 5 pi minus pi over 5 plus I sine of 5 pi minus pi over 5, and this will be equals to 2 cos of pi minus pi over 5 plus I of sine pi minus pi over 5. Right. Now if we check this, now I want to check what quadrant is this on, right? So we're going to come here and but it's fine, let's not take that. Let's just do this. We can draw now to check what quadrant is this on. This is first quad, this is second, this is third, this is fourth. Here, this one is where we're having here we have, let me do this, 2 pi plus theta, pi plus theta, No, here it's minus theta, because this is pi, right? And then here it's pi plus theta. Here it's 2 pi minus theta. Now, since we have this, right? And here, don't forget it's pi over 2, meaning that this one also makes it to be pi over 2 minus theta. If we wanted to add to expand our knowledge, right? This would also make it to be like that. So now at this one, given that it's 3 pi over 2, I've shown you that. Why is it 3 pi over 2, right? Meaning that this one would be 3 pi over 2 plus theta pi over 2 minus theta. So, but these ones, we can just leave them out for now, because we want to focus, our focus will always be on this one of pi. So we check this one. This one is pi minus theta, meaning that it's here. All right, meaning that it's in the second quadrant. And in the second quadrant, sine is positive. It's positive. Here cos, positive. Here tan. This divided by this, we get a tan, right? Tan is positive. And here they're all positive. So now we check, we say that we're in the second quadrant. It means that this one will be positive, this one will be negative. So we're just going to say this, the answer will be like this: 2 be 2 negative cos of pi over 5 plus I sine of pi over 5. Right? So now we check the second one. We are going to check Z, was this Z1 or was Z2? We check Z3. All right. So when we check Z3, we are going to have 2 cos of 2 pi 3 over 5, which is plus I sine 2 pi 3 over 5, which this is equals to 2 cos of 6 pi over 5 plus I sine of 6 pi over 5. And if we try to expand this, we're going to get cos of 5 pi plus pi over 5 plus I sine of 5 pi plus pi over 5. And this will be 2 cos of pi plus pi over 5 plus I sine of pi plus pi over 5. Right. Then if we check, this is in quadrant 2, because that's where we're adding theta. It's pi plus theta. And then this would mean that this is 2. No, let's check first. Here, they are both negative. Sine and cos are both negative. Let us check first before we do anything, right? It means that this would be negative cos of pi over 5 minus I sine of pi over 5. Alright, we will simplify further. Let me just continue. We have Z4, which is equal to 2 cos of 2 pi 4 over 5 plus I sine of 2 pi 4 over 5, which this will be equal to 2 cos of 8 pi over 5 plus I sine of 8 pi over 5. Right? So this, if we also try to expand it, we are going to get cos of, this would be 10 pi minus 2 pi over 5 plus I sine 10 pi minus 2 pi over 5. Those who can ask, why didn't I choose 5 pi plus 3 pi? The distance from 5 to 8 is 3, and the distance from 8 to 10 is 2. So I always prefer the lower distance or the lesser distance, right? I believe that you'll also prefer that. So now this would be, if we proceed, this would be cos of 2 pi minus 2 pi over 5 plus I sine of 2 pi minus 2 pi over 5. Then we check the quadrant. We are subtracting, we are saying 2 pi minus theta, right, which is in this quadrant. I'm sure we see that. So if we check, we're in this quadrant, the fourth quadrant, where cos is positive. So it means that this would be 2 cos of, cos is positive here, 2 pi over 5 minus I sine of 2 pi over 5. So you see this. So you can try to do B as well.